Good morning, students. Today we are going to see a topic 8085 interrupts. 8085 interrupts. 8085 has 5 interrupt inputs. That is trap, RST 7.5, RST 6.5, RST 5.5, INTR, that is interrupt request. These are the pin diagram of 8085 microprocessor. 8085 consists of 40 pins. From this 40 pins, 5 pins are interrupt pins of 8085. That is trap, RST 7.5, RST 6.5, RST 5.5, INTR. INTA. INTR is nothing but interrupt request. INTA is nothing but interrupt acknowledgement. Interrupt means interrupting the normal execution of the microprocessor. Okay, which interrupt the normal execution of the processor is known as interrupt. When microprocessor receives interrupt signal, it discontinues the operation, whatever it was executing. It starts executing new program indicated by the interrupt signal. Interrupt signals are generated by external peripheral devices. After execution of the new program, microprocessor goes back to the previous program. 8085 is executing its main program and interrupt is generated by an external device. At that time, 8085 passes the execution of main program. After that, it will call the ISR, that is interrupt service routine, and after that 8085 execute the ISR. After it return to execution of main program, that from where it was passed. This is the process of interrupt. ISR. Okay, ISR is nothing but interrupt service routine. It is a subroutine. Whenever 8085 calls an ISR in response to an interrupt request by an external device, ISR must be located in memory at predetermined addresses known as interrupt vectors. Sequence steps whenever there is an interrupt. Okay, whenever microprocessor recognizes an interrupt, it will follow the below steps. First step, microprocessor complete execution of current instruction of the program. That means microprocessor will stop the execution of current program. After that, PC contents are stored in stack. PC is loaded with address of the new program. After executing the new program, the microprocessor return back to the previous program. It goes to the previous program by reading the top value of stack. Classification of interrupt. There are 4 main classification of interrupts. First one, maskable and non-maskable interrupt, vectored and non-vectored interrupt, edge triggered and level triggered interrupt, priority based interrupt. Maskable interrupt. Maskable interrupt are those interrupts which can be disabled or enabled. This disabling and enabling is done by software instructions. The example for maskable interrupt or the list of maskable interrupt in 8085 are RST 7.5, RST 6.5, RST 5.5 interrupt request. These 4 pins are the maskable interrupt pin of 8085. Next, non-maskable interrupt. The non-maskable interrupts are always enabled mode. Okay, that is called as non-maskable interrupt. These interrupts cannot be disabled or enabled by any software instruction. Example for this non-maskable interrupt is trap. Okay, TRAP, trap is a non-maskable interrupt. Next, vectored interrupt. The address to which program control goes, RST 7.5 memory address or vectored address 003C, RST 6.5 0034, RST 5.5 002C, TRAP trap 0024. Here, the absolute address is calculated by multiplying the RST value with 0008H. Non-vectored interrupt. The interrupt which don't have fixed memory location is called as non-vectored interrupt. The address of the memory location is sent along with the interrupt. Here the example for non-vectored interrupt is INTR, that is interrupt request is a example for non-vectored interrupt of 8085. Edge triggered interrupt. This is another type of interrupt in 8085. The edge triggered interrupt is nothing but which are triggered at leading or trailing edge are called edge triggered interrupt. The example for edge triggered interrupt is RST 7.5. It is triggered during the leading edge, that is nothing but positive edge. Next, level triggered interrupt. This interrupt which are triggered at high or low level are called level triggered interrupt. The interrupt pins RST 6.5, RST 5.5 interrupt request are the example for level triggered interrupt, and trap is edge and level triggered interrupt. Priority based interrupt. Whenever there exists a simultaneous request at two or more pins, then the pin with higher priority is selected by the microprocessor. That is called as priority based interrupt. This priority is work only when there are simultaneous requests. Okay, this priority based interrupt, that means priority of interrupt. Trap has highest priority, that is first priority. RST 7.5 has second priority. RST 6.5 has third priority. RST 5.5 fourth priority. INTR is the fifth priority. Okay, this all about the interrupt of 8085. Thank you.